until now, we have only learnt about combinational circuits. So what are combinational circuits? Let's say there is a circuit that is given as in the block diagram here, and let's call it circuit 0. Okay, let's say it's circuit 0, and we have three inputs, okay, namely as D, E, and F, and the output is given as Z. Okay, and they are saying, okay, at a specific point of time, let's name that time. Let's say T is equals to 75. Okay, at a specific point of time, okay, D is equals to 0, E is equals to 0, and F is also equals to 0. Then the output will be equals to 1. This is what they are saying. When T is equals to 75, by that, what do I mean is, on the 75th second, at that specific moment, okay, at that specific moment, D is equals to 0, E is equals to 0, F is equals to 0, then the output Z is equals to 1. Okay, Z is equals to 1. What you have to understand from this is, okay, only D, E, F at T is equals to 75 affect the output Z at T is equals to 75. Okay, at T is equals to 74, there would have been different inputs and a different output. And at T is equals to 76, the inputs can differ or the output might differ based on the inputs. Okay, but what you have to understand is the T74 at T74, Z could have been anything, right? Z could have been anything. So let's name it as Z74. Okay, let's name it as Z74. And at time 76, it could have been any output. So let's say this Z76. Okay, Z76. What you have to understand is Z74 does not affect Z74 does not affect Z75. Okay, Z74 does not affect Z75. Similarly, Z75 does not affect Z76 because this is a combinational circuit. Okay, because this is a combinational circuit. In combinational circuits, only the inputs decide what the output is. Only inputs decide, which means D75, E75, and F75 decide Z75. Similarly, only D74, E74, and F74 decide what the output Z74 is. Similarly, with Z76. Okay, so you have to be very careful in combinational circuits, only the current inputs. Okay, in combinational circuits, only current inputs are taken into consideration. Okay, so what does this mean? Well, let me give you some points. There is no memory. The concept of memory does not exist. Okay. In this combination circuit, it doesn't remember what happened at time 75. It doesn't remember what happened at time 74. Similarly, it doesn't remember what happened at T75 when it moves to T76. So there is no memory. Okay, there is no memory. And the second one is the examples. Okay, we have to know the examples, some of the examples. Any normal logic gate is a combinational circuit. Okay, any AND gate, any OR gate, anything is a combination circuit. But if you have to know some better examples, half adder, okay, half adder, or full ladder, okay, full ladder, or multiplexers, decoders, they are all combinational circuits. They do not have the concept of memory. They are only affected by the current inputs, the states of the inputs at the moment. D75, E75, F75 affect Z75. Okay, that's it. That's it. And another important thing is instantaneous response to input changes. Instantaneous response to input changes. Just that's because there is no memory. It doesn't have to refer to the previous states. So whatever you give at the moment for the inputs, the output will read them. I mean, the gates will read them and give out the specific output. That is the idea. This is what we call the category called the combinational circuits. Okay. And there is the opposite. Okay. There is the opposite, which are called the sequential circuits. Let's say we have a circuit block. Okay, let's say we have a circuit block and let's call it S0. And let's say there are three inputs A, B, and C. Okay, and there is the output F. And then there is also another output. Let's call it as G. Okay, let's say we have two outputs here. There can be two outputs because we learned in half adders and full adders that we can have if you have a block of circuit. Okay, you can have two or more outputs if you arrange gates in a specific manner. That's it. Now let's talk about this. Okay, so let's say when t is equals to 75, we know A 75 is given and B 75 is given and C 75 is given. Okay, let's say they are 1, 0 and 1. Okay, fine. But they can't say what F will be based entirely on just these three inputs. Okay, they can't say that because they are saying F also depends on F74. F75 also depends on F74 plus A75. The previous second, what happened in the previous second, t is equals to 74. So this there will be A74, B74 and then C74. There will be these inputs. Other than that, based on these outputs, there will be F74, but F74 will depend on F73. Okay, F74 will depend on F73 plus A74. This is the beauty of a sequential circuit. It can remember, okay, it can remember what happened in the previous second. Therefore, the output of the previous state, okay, the output of the previous state also affects the output of the current state. And the important part is, okay, when t is equals to 76, we know F75 will affect F76 because F76 is given as F75 plus A76. That's the idea. What happens is F73 affects F74, F74 affects F75, F75 affects F76, and so on. Just to generalize this, I'll say Fn will be affected by Fn minus 1, where n is time parameter. So in combinational circuit C, only Z will be in this case if D equals to E is equals to F equals to 0. Let's say Z is equals to D plus E plus F whole thing bar. Okay, it could be a possible Boolean expression. In this case, you can see there is no idea of the time. Time really doesn't matter here. Okay, because you are not remembering the previous state. But here, time is an important part. Time can change the behavior of the output because Fn is given as Fn minus 1 plus An. A at time specific time n and F at specific time n minus 1. That decides what Fn is equals to. Okay, let's say if F73, okay, let's say F73 was equals to 1 and A74 is equals to 0. Then F74 will be equals to 1 plus 0, so it will be 1. And now here we come back again. So it will be 1 plus 1. So F75 will also be equals to 1. And since we know F75 is equals to 1, and we doesn't really need to know A76 because obviously 1 plus anything will be 1. So F76 will be also equals to 1. So this is how sequential circuits work. Okay, this is how sequential circuits work. What do I mean by this? Well, they have the concept of memory. Okay, they contain memory elements. Okay, they have memory elements, which we are going to learn in the next video. Okay, which is called the flip-flops. They are the very simple memory circuits that are used, and I'll teach you how it works. Okay, and this is used for storing data. Anything, the static RAM or the registers you work with in the computers or any counters that you are going to use. Okay, they all use memory. Okay, and they require sequential circuits. Literally, okay, literally, if you don't have sequential circuits, you won't have computers. Okay, there is no one Neumann architecture. Okay, there is no stored program concept. No, there is nothing there. So sequential circuits are far more important than just theory. Okay, they are not just theory; they make everything possible. Okay, and then as I said, sometimes they don't even need new inputs. Okay, sometimes they don't even need new inputs. They just work with the earlier inputs. Okay, so we can say doesn't need a new input, doesn't need new inputs to operate. New inputs to operate, to operate. So that those are the important parts. Okay, those are the important parts. Uh, we are going to learn about flip-flops in the next video. Okay, we are going to learn about flip-flops. Let me introduce that idea also before we jump in and start drawing things. Okay, flip-flops are built from logic gates, obviously, and they can store one bit of information. Okay, they can store one bit of information. I haven't told you how this works, not yet. Okay, I have just told you this is the function of them. Okay, this is the function of sequential circuits. I have not told you how this works. Okay, but I'll give you an idea. Okay, I'll give you an idea. The outputs are fed back into the system. Okay, the outputs are fed back into the system. Fed back into the system. Okay, they are. What do I mean by the outputs are fed back into the system? The F74, okay, F74 is sent into the system, okay, is sent into the system or fed back into the system to calculate F75, okay. That's how they are connected. That's how they are connected. F74 is fed back, and this specific thing is called as feedback. This phenomena is called as feedback because the output is sent back into the circuit. The output, okay, the output is remembered even after the inputs are removed. Okay, the output is remembered. Output is remembered even after the inputs are removed. Okay, after inputs are removed, the outputs are still remembered. Okay, so that is another thing about flip flops. They can toggle state. Okay, they can toggle state on each valid input pulse. On each valid input pulse. Okay, that's the idea. Like a push button. Okay, like a push button. When you push the button, it will work, and when you remove your hand, it will stop working. So it can toggle state on each valid input pulse. Then, since it can toggle states, okay, since it can toggle states before a transition, okay, before a transition, okay, before a transition, or you can say if for a transition to occur, okay, the input must return to inactive state. The input must return to inactive state. Okay, the input must return to inactive state. That's it. These are some of the important points that you should know about flip-flops. In the next video, we will be talking about reset set flip-flops, which are the basic blocks for learning any other flip-flops. This is the entry point for you to learn about flip-flops. So don't forget to watch that video to understand how a flip-flop works. Thank you for watching the video on how to understand the differences between combinational circuits and sequential circuits. If you found this video helpful, don't forget to like, share and subscribe for more lessons. I'll meet you in another lesson, and until that, keep learning and stay curious. Bye-bye.